All right, good day and welcome back to our session, Krazifizix Medicine Science Clinic, Entertainment Clinic. All right, www.krazifizix.org.za. You have our number there, 0817442103. And that's the face behind the voice, yeah. That's the man there. All right, because many people are saying we want to see this guy, and here he is. All right. Surname is Komalafe. All right. His surname is Komalafe, popularly called Bishop. All right. Popularly called Bishop. All right. I'm originally from Nigeria. All right. I'm originally from Nigeria. All right. Great. So today we continue with our physical science paper. We continue with our physical science paper, which is our paper 1. All right, just in case you get this video first, this is not the first video, this is part B. You need to get part A as well, because you now have a full paper at your disposal. All right, now this question is talking about momentum. The diagram below shows two skateboards, A and B, initially at rest. I said something, let's try to always analyze, initially at rest. All right, with a cat standing on skateboard A. The skateboards are in a straight line. Why are we talking about straight line? We're going to talk about linear. All right. One in front of the other and a short distance apart. The surface is flat, frictionless. Frictionless talks about an isolated system now. Isolated system. Okay. Now look at the first question, 4.1. You should be expecting to answer such a question in an exam. 4.1. State the principle of conservation of linear momentum. What does it state? The total linear momentum. Let's make it very simple. The total linear momentum in an isolated system. Is conserved. All right, is conserved. As simple as this, you get your 2 marks there. The total linear momentum in or of an isolated system is conserved. All right, there are different ways of putting it. Some learners will say in an isolated system, the total linear momentum before collision is equal to the total linear momentum after collision. All right, it's still the same before collision and after collision, and that's the formula there that we would be using later on. All right, so you have your 2 marks there. Now, each skateboard has a mass of 3.5 kilograms. Each skateboard has a mass of 3.5 kilograms, which we see right there. The cat of mass 2.6 jumps from skateboard A with a horizontal velocity of 3 meters per second and lands on skateboard B with the same velocity of 3 meters per second. Refer to the diagram. Now, do you notice both skateboards were already at rest? The cat jumps from one to the other. We need to understand the question in order for us to be able to deal with the question effectively. All right, now, what are we looking for in this question? Let's scroll up and see. Okay, it's 10 marks, and then already we have our 2. We need to go on and get the remaining one. Calculate the velocity of the skateboard A just after. Now, it is important to start by stating your direction. Okay, let's take the direction of the cart as positive. All right, which is basically forward, as positive. Now, let's write the things that we know in this question. Let's put all the things we know down in this question. Okay, we know the mass of the cart, which we can say probably M1, mass of the cart, and that is 2.6 kg. All right, and mass of the skateboard is 3.5 kg. Remember, now there are 2 skateboards, so we just use one for A and one for B. Now this talks about momentum because jumped after from it. We're looking for A. Now what do you notice? Before the cat jumped, okay, each skateboard has a mass. The cat of mass A jumps from skateboard A. So, okay, we have the skateboard there, all right. Not a good artist. And then we have a cat there, all right, which means before the cat jumped, this system is all stationary. Then what happens? The cat now leaps off, which is now a final. So if we want to deal with this, we would then say, now do you see that this one is combined? So let's start like this. It is important that you write this formula first. Okay, now this cart and the skateboard are together before and after. What happens? All right, the cat, this is the cat leaping off, they are separate. So together, and what do we have here? Separate. This will inform you of what your formula should look like. Now if they are together, what do? We add the masses m1 plus m2 because they are together. We talk about initial velocity, and then now they are separate. Each one has its own final momentum, m2 vf2. I hope this makes sense. Look at the question very well. Together, and now they are after. All right, so let's see if they are together. What is m1, which is the mass of the cart, is 2,6 plus mass of the skateboard 3,5, 0. Then mass of the cart again we said 2,6. By the way, the cart jumps at 3 meters per second to the right. Remember we said direction of motion of the cat is positive. So this is positive 3 plus 3,5. I do not know this velocity, the final velocity of cat A. Now mathematically, what do I have here? I've got a 0, which is equal to, now what is 2,6 times 3? You must learn to do this without calculators as well. 3 times 6 would give me 18 there, all right? 8 there, and then 2 times 3 will give me 6, plus the 1 from the 18, that will give me 7, plus 3,5 VF2. Okay, what do? We can move to 3,5, all right? I want us to make the maths very easy. Equals to 7,8. Now what do? We divide both sides by negative. VF2 therefore equals to 7,8 over 3,5. Okay, let's go get our calculator quickly and calculate this. What do we have? 7,8 divided by 3,5. And what do we have here? We've got 2,228, which when we round off now would be a 2,23. Remember, this is a negative. So what do I have here? I'm going to have VF2 equals to it's 228, but we round off to 2 decimal places, meters per second. Now remember, it's negative. We said the direction of the cart is actually moving to the right, and we said it is positive. Now if we get a negative answer, what does it mean? It's the opposite. That means the skateboard A is actually moving at 2,23 meters per second to the left. And we're fine. You get your 5 marks there. All right? 5 marks. Let's see how this will be marked in an exam so that you see where the 5 marks just, come out from. Now, your formula, you get 1 mark there. Your substitution here, you get 1 mark. All right? You get another mark there. All right? You should be getting another mark here. It depends. Sometimes you might not. You might just get, okay, let's put 1 mark for all of this. 1, 2, 3. And the final answer, 4 and 5. Why are we marking direction? The question says calculate the velocity. Grade 10. Velocity is a vector quantity which has both what? magnitude and direction. So it's important. It's very, very important. Now, you see now here, you get a mark for writing the direction. Great. But if the question had said, calculate the magnitude of the velocity, then you would not need a direction. But in this case, we need our direction. All right, great. Look at the next question now. Immediately after the cat had landed, the cat and skateboard B move horizontally to the right at 1.28 meters per second. All right, let's look at this. The cat now lands on B. Okay, they were separate before as well, and now final, which is almost the opposite of that. But they now move together at 1.28 meters per second to the right. So we have a positive. Here we have VI of this is 0, stationary. But the cat has a velocity of 3 meters per second. Calculate the magnitude of the impulse. Guys, definition here is key. What is impulse? We'll define impulse quickly. Impulse, it is the product. It is the product of net force and time taken for the force to act on it. Time taken for the force to act. All right, time taken for the force to act. That is impulse. Now, if I say product, what does product mean? It means multiplication of the net force and what? Time. So what is my impulse formula? My impulse formula is simply, and you'll get this on your formula page as well. My impulse is now simply F multiplied by delta what? T, F net. Okay, let's write this well. And if you go to your formula page, please run to your formula page and find this formula. F net delta T. Now that is impulse. Now, if you look at this question, we have a challenge. We do not have the force and we do not have the time. But in your exam, your formula page, this formula is now written this way. F net delta T equals to delta P. And this is what? Change in momentum. Okay, before we calculate, remember we're doing this and we're going deep. What is the unit of impulse? Unit of impulse is newtons second, because it's newtons times second. Your change in momentum is simply final momentum minus initial what? Momentum. And already I'm sure we know the unit of momentum. Momentum is mass times velocity. Another definition there. Momentum is the product of mass and velocity. So what's my unit? The unit of mass is kilogram. The unit of velocity is meter per second. All right? And this is now plus direction. Okay. Now, in this question, what do you notice? We do not have this. But this entire quantity is equal to this. Let's check. Can I use my delta P to calculate? Can I use my delta P? Now, the question says, calculate the magnitude of the impulse on the skateboard B. On the skateboard B. Let's see why I'm stressing that. Change in momentum is mass, final velocity minus initial velocity, because it's simply m delta v. But which object am I going to use here? The question says on B, so let's stick to B. If I use B, then I've got to use the mass of skateboard B, the final velocity of skateboard B, and the initial velocity of skateboard B. Please do not use the mass of the cat and mix it up with the velocity of the cat, of the skateboard. If you are using the cat, we can also use the cat to calculate. All right, we'll try that. We can use the cat to calculate all through, or we can use just the skateboard alone. So, because the impulse should be the same according to Newton's third law. I'm going to prove that to you just now. So if you are dealing with the skateball, the skateboard, please use the skateboard all through. Now, what is the mass of my skateboard? It is 3,5. Now, what is the final velocity? Remember, we were told the skateboard now moves 1,28 to the right, 1,28. What's the initial velocity of the skateboard? Both skateboards are at rest, initially at rest, so it's 0 there. Now, if you multiply, what's my answer going to be? Let's check our calculator. Please also get your calculator and multiply with us. Times 1,28. What's the answer? The answer is 4,48. 4,48. But guys, remember, in this question we were told to calculate impulse. Although we use change in momentum, my unit should remain as the unit of what? Impulse, which is force times time, that's Newton second. All right, let's check something here. What if I decide to use that of the cat? Let me use a C. Mass of the cat, final velocity of the cat, initial velocity. Remember, I don't want to mix them. It's cat, 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 board, board, board. Cat, 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 board. Now, what is the mass of the cat? The mass of the cat is 2,6. What is the final velocity? The cat is now on the skateboard, so they move together at 1,28. And what is the initial? The initial of the cat, it's coming in with what? 3. Positive 3, remember? Okay, let's put all of this in our calculator. What are we talking about? 2,6, let's open a bracket, 1,28 minus 3 plus the bracket equals to, now what do we get? Negative 4,472. Negative 4,472. Negative 4,472. All right. Negative 4,47. All right. Newton second. Now, if you check your answer here, our answers are quite close. 4,48 and 4,47. 4,48 and 4,47. So that's what we have. Now, why is this negative? Let's check something here. Both objects, the cat and the board, spend the same amount of time on each other. So T of the cat is equal to T of the board. According to Newton's third law, if object cat exerts a force on object board will automatically and simultaneously exert the same one force, equal in magnitude, but what? Opposite in direction. Opposite in direction. So, but we're saying, so F of C will be equal to F of B. But now, in direction, we are going to have what? A negative. But in magnitude, they'll be the same. So if my F and my C, T are the same, check this now. It simply means F net delta T of the cat, let me put C outside, should be equal to F net delta T of the board. By the way, what is this? Change in momentum of the cat should be equal to change in momentum of the board. Now, do you see that? That's why we got the same answer. But we now said it must be equal in magnitude, but what? But opposite in direction. Because examiners can ask you, without any further calculation, use a law of physics. What you need to do is to use your Newton's what? Third law. And you're done. Beautiful there. You have your 10 marks, 1 for the formula, 3 marks, 1 for the formula, 1 for the substitution, and 1 for the unit. Awesome. All right. So that's how we work through questions like this. Manipulation of formulas, direction, because it's a vector quantity, is very key. Okay. Now let's move to question number 5. Question number 5. I'm sure a lot of learners are waiting. A lot of learners are waiting for this: work, energy, and power. Question number 5. A slide PQR at an amusement park consists of a curved frictionless, again, frictionless, a curved frictionless PQ, and a section QR which is rough. All right, QR is rough. We're talking about friction. Straight and inclined at 30 degrees. Now that's my 30. Please read that question and look at the diagram. The starting point P is 3 meters. Okay, hold on. The question says a slide PQR consists of a frictionless section PQ. So here, what do we know? It is frictionless. Okay, which is that, all right? Now, the starting point P is 3 meters above Q, okay? And the straight section QR is 5 meters. I'm sure you can see the 5 meters here. Number 1, state the law of conservation of mechanical energy. Again, what do we know? The total, just like our linear momentum, the total mechanical energy in an isolated system, now these are 2 free marks, is conserved. You get your 2 marks there. You're not wasting time. The next question says, calculate the speed of the learner at Q. Now, what do we notice between P and Q? Between P and Q. Now, a learner with mass 50 starting from rest. Now, it means my initial velocity here is 0. Slides down. I'm going to get somewhere very important and very interesting here. Slides. When something slides down, it means there is no applied force. Okay. Now I'm going to teach something here very quickly. When we talk about forces, there are 2 types of forces: conservative, and conservative forces. Non-conservative. All right. Okay. Conservative. Okay. I'm going to share an expensive joke just now, but just for science, that's why they say it's crazy. Now, what is non-conservative and conservative? Let's quickly define. Let's define conservative force. It is a force for which the work done does not depend, or is independent. Some other textbooks will say does not depend, whichever one you're comfortable with. Does not depend on the path traveled. Please master this definition. And an example of this force is simply the force of gravity. Another example is your electrostatic force. Okay, but just in this question, we're going to deal with just gravity alone. So it's a force for which the work done is independent on the path traveled. That is your conservative. What is non-conservative, therefore? Non-conservative. Non-conservative. All right? It is a force for which the work done is dependent. You just basically changing on the path traveled, taken, whichever one, path traveled or path taken. Now, guys, here is my expensive joke. Non-conservative force. Now, when you think about something that's non-conservative, that has been in abundance, when you talk about conservative, you talk about you reserving stuff. All right, conservative. And here I'm gonna have conservative. Okay. Now, basically, we're saying when something is non-conservative, you have abundance. All right, abundance. And this is actually when something is abundant. When somebody is abundant, we say that person is fat. All right, so non-conservative simply means what? Fat. Now, if you can think about it like this, what does my fat mean? Remember, fat, abundance, non-conservative. Fat simply means friction, applied force, and tension. Now, these are examples of non-conservative forces. Awesome. What about conservative force? We said what? Gravity and electrostatic force. But for this particular topic, let's leave it like this. Non-conservative is fat. Great. And you'll be able to attempt your questions. Now, let's look at 5.2. I'm going to look at two ways, which is basically the same, but we'll look at two ways of doing this. Calculate the speed of the learner. Remember in 5.1 we had said mechanical energy is what? Conserved. Now, what is my mechanical energy? Now, just like linear momentum, we used initial and after. So if I'm using mechanical energy as well, I'm going to use mechanical energy before and what? After. Or mechanical energy at point A equals to mechanical energy at point B. Let's define mechanical energy quickly. It is the sum of kinetic and what? Potential energy. It is the sum of kinetic and potential what? Energy. Great. Sum of kinetic and potential energy. So if I'm now saying E mech at point A or at point P must be equal to E mech at point Q. Now, this formula is not there on the formula page like this, although I'll show you how you can quickly get to this. Now, what is my E mech? It is EK plus EP all at point P. Now, I can only use this effectively in my isolated what? System. Remember now, here, there is no fat. There is no fat, which means it is a, here we don't have fat. It means it's a conservative what? System. All right. Calculate the speed. Now, let's see. What is my kinetic energy? It's half mv squared plus mgh at point P equals to half mv squared plus mgh at point what? Q. Now, guys, I am going to use my Q as my point of reference. This has always been quite challenging for some learners. All right. Let's substitute. Half. What is the mass of the learner? 50. Initial velocity is what? 0 squared at P. Remember, at rest. Plus, now what is the mass again? 50. What is G? 9,8. Guys, we're dealing with energy here, so we don't pick direction. Energy is a scalar quantity. Energy is a scalar quantity. Now, what about H? What is the height of P? The height, now I'm dealing with P and Q. What is the height of P from Q? It's 3 meters. Equals to half. What is the mass again? 50. I do not know the velocity. That's what I'm looking for. A speed. What is the mass? 50. What is G? 9,8. Now, what is the height at Q from Q? Remember, we said height of P from Q and height of Q from Q. It's 0. So we can substitute quickly. All of this would give me 0, and all of that would give me 0. So what is 50 times 9,8 times 3? Please get your calculators out. 50 times 9,8 times 3. What do I have? 1470. All right, so I have 1470 equals to 25 V squared. What do I do? Divide through by 25. All right, and then what am I going to have? Let's do this very slowly for everyone's ability to understand. We divide by 25. Okay, some of you see what I'm going to do already, and some of you already have the answers. 58,8 V squared equals to 58 comma 8. Now what do we do? It's a square there. Can we then square both sides to remove my square the power 2 there? All right, so what do I have? The square root of my answer. I hope you see the way I'm using my calculator. I'm just cropping in my answer, and that gives me 7,668. 2 decimal places. We can now say our answer is what? 7,67 meters per second. All right. Now that's one way. You get your 4 marks there. Where's the 4 marks? 1 for the formula. All right. 1 for the left side substitution, 1 for the right side substitution, and 1 for the answer. Remember, we're looking for speed. It has no direction. Okay, let's try something else, a different method. We said there is no fat here. No fat. None of these forces. So there is no non-conservative. That's what we're saying. Which basically means that these guys are not doing any work. My work done by non-conservative is equal to 0, because there is no non-conservative force. All right. Now, if you go to your formula page, you would find a formula that says work done by non-conservative. The beauty of this one is you have the formula on the formula page. Change in kinetic plus change in what? Potential. Actually, it is the same like the first one. But just in case you forget the formula, run to the formula page and ask yourself, do I have any fat force? If your answer is no, then work done by non-conservative becomes what? 0. Now let's substitute here. 0. Okay, let me still keep this because I like to do my substitution at the same time. Change in kinetic energy simply means half m Vf squared minus Vi squared. Okay, change in kinetic energy. Change in potential will be final potential minus initial potential. Some learners are saying, how did you get this formula? Let me quickly re-explain. I've got all the time for you. From here, I would say, okay, let me just do this on one side. It simply means final kinetic minus what? Initial kinetic. Because I want this video to be beneficial for every learner. Now, my kinetic energy is half mv squared, but I'm dealing with final. And half what? mvi squared. What do you notice? Half m is common to both sides. So can I bring that out? Half m, what am I left with? Vf squared minus vi squared. Please and please and please, I want to say this, and I'm going to write this in red. Please rewind this to get what I'm saying here. Half m Vf squared minus Vi squared is not the same as half m Vf minus Vi squared. This is completely wrong, because now if you expand this, you're not going to get this. This is difference of 2 squares. Please avoid such mistakes. And what is my kinetic, my change in potential is what? Final potential minus what? Initial potential, which is what? mgh final minus mg. You remember this from grade 10. What is common? mg. So what do I have? hf minus what? hi. That's how we get those formulas. All right, so well, let's go back to what we said. So is it okay to now say work done by, I hope you're right, so that you can just catch up as fast as you can. This is half m Vf squared minus Vi squared plus mg h final minus h what? Initial. Work done by non-conservative, there is no fat, 0. Half 50. What is the mass? What is the final velocity? I do not know. What is my initial? 0 squared. Plus, what is m? 50. What is g? 9,8. What is my final height? Now, the object is starting from here and going down. My final height is at q, which is what? 0. Okay, my final height is at q, and that is 0. Okay, let's scroll down here. My final height is at q, That is 0. Please be careful. Go back to the question to get values. And my initial, I am starting from P, and that will give me what? A 3. Now, what will this give me? 0 here equals to 25 VF squared. Now, what is 50 times 9,8 times negative 3? We did that earlier on. If you do that, you're going to get negative 1470. Now, can I move the 1470 over to the other side so that you see that it is... Now, do you remember this? If you were writing, you would actually say this now. Divide both sides again by what? 25 by 25. And we need to find the square root like we did. VF now equals to what? 7,67 meters per what? Second. This is using your energy principles. Using energy principles. So just in case you forget the mechanical energy formula, please run back to your work done by non-conservative. No non-conservative force, we automatically get a 0. All right, on that force. Now, 5.3, draw a labeled free body diagram showing all the forces, all right, for the learner while he or she is on section QR. Okay, and I need a new page. All right, a free body diagram. Now, what do we know? Let's go to the question. They said on QR, the first thing I remember on QR is what? Friction, because it's rough. Friction is a force that opposes what? Motion. Now, it's a free body diagram. So what am I looking at? The learner is on a surface. So there's normal force. Every time there's a surface, there's normal. Your normal must be perpendicular to the surface, straight line. All right? Normal must be perpendicular to the surface. Okay? What do I know? There's always gravity, right? And if the object is moving down, friction must be acting in the opposite what? Direction. All right, please, friction doesn't oppose applied force. Learners have that mentality. Friction will not oppose applied force, or not always. It's not a statement of fact. Friction will oppose the direction of motion. Okay, my free body diagram, check on the videos. I'm going to do one of the questions. Now, this is my force of gravity, or let's just call it weight, or FG, force of gravity. Now, what do I have? I have my normal force. Remember, your normal force must be perpendicular. Now, friction, the object is moving down. Friction is also parallel to the surface. Friction. Now you have your 3 marks. Please be careful of how you draw your free body diagram. Be very careful how you draw your free body diagram. It's a dot and then the lines. What you can do in an exam is to use a pencil to draw a line there so that you have a parallel. And when you are done, please clean that pencil. We don't want to see the plane. On free body diagrams, there are no planes. It's just forces and a dot. When I talk about a force diagram, then, in fact, I want to draw a force diagram for you here, quickly. In case the question says a force diagram, show us the plane. All right? Use a box. The weight of the object will start acting from the center. Weight. Or force of what? Gravity. Then normal force acts from the surface of the object. You see, it's touching there. All right? It must touch there. And what is this? Normal force, because it's perpendicular to the surface. Friction now is on the surface. On the surface, friction. That is your force what? Diagram now, friction. FK. That is your force diagram. I need you to see the difference. Friction is on the surface. Your force diagram tells us exactly where the forces are acting. Normal force is from the surface, gravity is from the center. So please take note of these differences. Now, having drawn this diagram, it is important not to just run through the calculation. So look at what I'm expecting you to do. Okay, here's your free body diagram, FK, and what do I have here? Normal force, Fn, and what do I have here? Fg. Immediately on the side, All right, on your rough page, quickly draw another force where you have resolved. Okay, here I'm going to have normal force. Here now I am going to have what? FG perpendicular. And here I'm going to have my friction as usual. Here I am going to have FG parallel. These two are components of the force of what? Gravity. But they must always be acting what? Down. This one here is horizontal, or what we call parallel. And this one here is vertical, which is opposite your normal force. Again, this is grade 11. Before you go on to calculate, listen, I want this to be simple for you. You need to go over this section again. When you draw this diagram, all right, what we say is friction has a surname, just like any other person. You have your name and you have your surname. All right. To make it interesting, we give friction a surname. And the surname of friction is 180. So you write the name and the surname, friction 180. Now, this is a straight line. If this is 180, the one opposite becomes a 0. Just put it there. You see how I'm going to use it. Some of you already see where I'm going. Finally here, please write down the formula of this thing here. And the formula here. These formulas are not on the formula page. We expect every learner to know it. This is mg sine alpha. I'm using alpha. I'll tell you why I'm using alpha. Theta has been a bone of contention, and to my understanding, I think it is wrong. All right. Here is mg cos alpha. Okay. Please remember, we are doing physical what? We are doing physical sciences. Okay. We're doing physical sciences. When it comes to gravity, do physical science by saying physical, P, parallel, S, sine. So when it is FG parallel, what do you use? Sine. And that makes your life very, very easy. Good. So I'm going to refer back to what I just did right now, and I hope you got that. If you did not get it, please rewind. Get it before we go to the next, before you continue to the next calculation. Now, we're given this. Let's read on. The coefficient of kinetic friction, I love this. This is grade 11. Is equal to what? 0,08. What am I going to say on coefficient here? Listen. Coefficient number 1 has no unit. Has no unit. Because it is a ratio of forces. Number 2. A change in the angle. A change in the angle of the plane. Angle of the plane, in this case, is 30, will not affect coefficient of friction. This is grade 11. It will not affect the coefficient of what? Friction. Okay? The only thing that affects coefficient of friction is affected by the roughness of the surface. By the roughness of the surface. Now look, this is more teaching than just revision. Roughness of the surface. Some of you are hearing some new things while we're revising. Okay. Now the question says, we are given the coefficient of friction. All right. Calculate the magnitude of frictional force. If you remember your grade 11 exam, grade 11 formula, I know some of you are actually there right now. Just saying, frictional force is mu kn, where your n is normal. N is normal force. All right. Now, what do I know? In my diagram, okay, you need to have that diagram down. What's my coefficient of friction? It's okay. I want to do something here. What is my normal force? I'm going back to my diagram very quickly so that you can see what I want to do here. Now here, do you see, let me use a black one, my normal force is now opposite my FG perpendicular, Newton's third law, equal in magnitude but opposite in what? direction, which means my normal force is also equal to mg cos what? Alpha. Very key, grade 11 concept. All right, mg cos alpha. So can we now go and substitute there? And then we say mg cos what? Alpha. Mg cos alpha. What is my mu k now? It's going to be 0,08. What is the mass? 50. What is g? 9,8. And cos 30. All right, let's run to the calculator quickly. 0,08 multiplied by 50 multiplied by 9,8 cos what? 30. 30. What do I have? I have what? 33,948. 33,948. All right, which is 33,95 newtons. Guys, you have your 3 marks. 3 marks. One for the formula, one for this, and one for that. Please do not forget this. Mg cos alpha. Very key. Use energy principles to calculate the speed of the learner at point R. I'm going to try to work out about 2 different options here. You choose whichever one. There are so many options that we can actually use. But I want to just run through. Let me run through 2 simple ones. What are we looking for? We're looking for the speed of the learner at point R. Okay, let's work with my diagram. What do I know? The speed here is what? 7,67. I'm looking for the speed here, which is my final. Okay, here now when they say energy principles, please, you must be able to state your work energy theorem. Work energy theorem. What I do is I write down the formula and interpret. What's my formula? It's written like this. W net equals to that. Now, if you were to read this, what would you say? Work net or net work done. All right? The net work done. What is this? It's equal. What is this? Change. And what is this? Kinetic what? Energy. Do you know that is your law, or that's your work energy theorem already? The net work done on an object is equal to the change in what? Kinetic energy. Okay, now let's quickly answer this question. Work net equals to change. The word work net simply means all the forces. Now, how many forces are acting in this question? Again, let me just draw. I have friction, I have normal, I have what? Fg perpendicular, and I have Fg parallel. Now guys, remember what we did under Newton's second law, question 2. All right, I will put a box here. This is how my object is moving downwards. So these are the forces acting on the object. Now this is 180. Again, this is what? So I'm dealing with friction and gravity. All right, look at this. So can I therefore say my work net equals to change in kinetic what? That's my original formula. Work done by Fg parallel plus work done by friction equals to half m Vf squared minus Vi squared. I hope you follow it. Now what is this? Now my original formula for work is, if you check your formula page, let me use something different. My original formula for work is F delta X cos theta. Okay, now if that's the case, I am now dealing with Fg parallel. So this force becomes Fg parallel. Now I would say Fg parallel delta X cos what? Theta plus, I'm going to friction now. This F becomes frictional force. Frictional force delta X cos theta equals to half m Vf squared minus Vi squared. But hold on, what is my Fg parallel? We did that. We said when it's parallel, we use what sign? Mg sine alpha. This is where I now explain to you what I was trying to say about the angles. Cos theta plus, okay, you got to follow this carefully because of my space. should now be equal to half m vf squared minus vi what? Squared. Now what is the mass? 50. What is g? 9,8. Psi, guys, if I use theta here, learners get confused of which one is which here. So it's high time we taught learners to use alpha for differentiation. Sine 30. Now what is my delta x? Horizontal movement, because we said that is horizontal now. It's 5. Cos, do you remember my diagram on FG parallel? I had a 0 there. That's where the 0 comes in. Plus, let's do with friction. What's my frictional force? We got 33, our friction was 33,95. 33,95. Remember, I think I still have it here. 33,95. Yes, 33,95. My delta x is what? 5. Now, what is the standard of friction? 180. And that now should be equal to half 50. What's my final velocity? It's unknown. My initial 7,67 squared. All right, what do we do now? We can put all of this in our calculator. All right, so we're going to do it. We'll do it together so that we all see how to deal with it. If you're not so good with your maths, just do it separately. 50 times 9,8. All right, sine 30. Make sure you close the bracket. Times what? 5. All right, cos 0. Close the bracket. If you don't close the bracket, you will get errors. 1, 2, 2, 5. All right, so the first one is 1, 2, 2, 5. Okay, on the next one, what am I going to have? I have what? 33,95 times 5 cos 180 degrees. And that gives me what? A negative 169,75. Negative 169,75. And that should be equal to 25. Remember, half of 50 is 25. Vf squared minus, now let's run to the calculator quickly again. What do we have? 7, what? 67 squared. What would that give us? 58,8289. Please do not round off. 58,8289. You are in the middle of a calculation. 58,8289. All right, what do we do? This we can solve. All right, or we can, okay, let's make it simple. Let's solve that quickly. 1225 minus 169,75. What would that give us? That would give us 1055,25. 1055,25. 1055,25 equals to 25 Vf squared minus 58,8289. Now what do? We divide both sides by 25. All right. Okay, calculator again. Just say divided by 25. I want to learn to carry our answers. 42,21. So 42,21. 42,21 equals to Vf squared minus 58,8289. All right, can we bring this one over to this side, and then it becomes what? A positive value. All right, we're going to need to work with me there. All right, so this is going to be plus. We bring that one, it's the plus. 58,8289, and that will give us what? 101,0389. Vf squared is 101,0389. What do we do now? We find the square root of both sides. What is my final velocity therefore going to be? We just come here and say square root of my answer, and my answer now is 10, what? 05 meters per second. Easy stuff there. All right, that's how you work things out. This is how you work things out there. Okay, let me run through another option for you. All right, and then you decide which one works with you. All right, Now I want to use my work done by non-conservative. If you go to your formula page, I just click this part so that I have space. Work done by non-conservative is change in kinetic energy plus change in what? Potential energy. We mentioned this formula a while ago. All right. In this case, fat. Which fat force do I have? Which fat? Okay, there's no applied. There's no there's no applied. FAT. There's no applied. There's no tension, but there's friction. Okay. So I'm going to come here and now say work done by what? Friction. We expanded this formula a while ago. So I'm just going to go straight into that. VI squared plus mg h final minus h initial. Remember, we're going to explain a whole lot of concept here. Now, what will this one be? We explained it earlier on. Fk delta x cos theta equals to half m vf squared minus vi squared plus mg h final minus what? H initial. What do we do now? Let's substitute quickly. Okay, but we're going to have a bit of a problem here. And I want to quickly help you with that problem. All right, let me clean this. I want to help you with that problem. And I need you to solve this. If you look at this, if you complete this, because that's my height now. Remember, I'm dealing with R and Q. I don't have this height. If I'm dealing with R, then this is 0. But I do not have this particular height here from Q or from R. But I see a right angle triangle here. I'm looking for this height. What will this be? This is my opposite, and this is my what? Hypotenuse. What does that mean? It simply means my sine 30 is h over what? 5. Cross multiply. H equals to 5 sine 30. Okay, if you're a math learner, you should know sine 30 is half. So 5 divided by 2 would be what? 2,5. That means my height is 2,5. So my friction, 33,95 delta x 5 cos 180. I'm sure you remember that right now. Half 50 vf squared minus vi squared plus, okay, because of space, because I want this to be very visible, plus 59,8. Now, what's my final height? Object is moving down. 0. Initial height, object is starting from 2,5. Guys, not P. We are out of this section. We are on Q now. 2,5. Okay, now let's do the maths quickly. 33,95 multiplied by 5. We did that a while ago, but let's just run through quickly again. 33,95 multiplied by 5 cos 180. With your math, you must know that cos 180 is negative 1. Negative 169,75. Okay, negative 169,75. Negative 169, negative 169,75 equals to 25 VF squared. Oh, by the way, guys, we do know our VI, which is what? 7,67 squared. All right, which is 25 into VF squared minus, I think it was 82. Well, let's do it again quickly. 7,67 squared. It is 58,8289. 58,8289. 58,8289. 58,8289. All right. Plus, can we do this now again quickly? Let's run through that and do that quickly. What am I going to have? 50 times 9,8, close the bracket, times what? 0 minus 2,5. What am I getting here? Negative 1225. Do you remember that number? Negative 1225. All right. Now, what do I do? If you write this down on a straight line, it becomes very easy. I'm running out of space. Okay. Now, I can move the negative 1225 to the other side, and it becomes what? Positive. All right. I'm going to have positive 1225 equals to 25 VF squared minus 58, comma what? 8289. Now, what would that give us? 1225, all right, 1225 minus 169, comma what? 75. What do we have? 1055, comma 25. 1055, comma 25. Can I divide both sides by 25, which is equal to VF squared minus 58, comma 8289. All right, dividing by 25, what do I have? I have 42,41, which is now similar to what we did earlier on, 42,41 plus 58,8289 equals to VF squared. I hope you know what I've done. Transposed again. So what do I have here? I will now have what? Plus 58, comma what? 8289. All right, and that will give me 101,0389. 101. So VF squared equals to 101,0389. 0389. What do I need now? I need the square root of both sides. And what's my VF going to be? What's my VF going to be? I just find the square root of my answer. And what is that? 10,05. Now we come back to the same answer. 10,05 meters per second. And that's work for you. That's work for you. Great. That's work done. All right. Now let's move to question number 6. All right. I think let's break down this video. I'll do question number 6 on a different video. Doppler effect. Because I don't want the video to be too long for concentration purpose, because now this is 1 hour already, but it's quite short. Let's add question 6, then we cut the video and do 7, 8, 9, 10 in another video. A police car is moving at a constant speed on a straight horizontal road. The siren of the car emits sound of constant frequency. Okay, emits. When you hear the word and when you see the word emits, we're talking about the source. Each of two observers, A and B, standing some distance apart on the same side of a road, record the frequency of the detected. Now, detected talks about the listener. Observer A records a frequency of 600 hertz, and observer B records a frequency of 610. Okay, something is going on somewhere. A is 690 and this is 610. Just by looking at this value, you can tell where the police car is going. The police car must be moving towards A, because that's why it's becoming higher. When a car is moving towards you, the sound produced by the car becomes higher. When it's moving away, the frequency becomes very low. State Doppler effect in words. It is very important that you are able to state Doppler effect correctly. Now, what is Doppler effect in words? It is an apparent change or a change, but we just like the word, an apparent change in the observed frequency. In the observed frequency. All right? As a result of the relative motion between a source and a listener. Between a source and a listener. Between a source and a listener. All right, that's the definition. Oh, already we answered 6.2. In which direction is the car moving? Choose from towards A or away from A and give a reason for your answer. What's our answer? Our answer, we said it's, okay, let me space. It's towards what? towards A. And why will it be towards A? Observer A records a higher what? Frequency. And that's your answer there. Now, determine the speed of the police car. Take the speed of sound in air as 340. Now, one common error that learners make is once they see two frequencies, they say one is the listener and one is the source. Guys, please read carefully. We do not have the frequency of the source. All right? We do not have the frequency of the source. Now, what do we need to do, or how do we need to work this out? I'll show you quickly. Now, this is what I do when I deal with Doppler. The formula has a positive or a negative sign somewhere. It's plus or minus. What we do is we use LS, listener before the source. Life is sweet. You don't say sweet is life. Life is sweet. On your Cartesian plane, when you draw a graph, do you remember that this is your positive x-axis and this is your negative? Because we get confused when I say towards is positive. It's just confusing. But if you work it out this way, it becomes easy. Listener and what? The source. Always the listener first when you use this method, and the source becomes the second one. Now, in this case, which one is stationary? Let me deal with A. I'm going to deal with A. Let me use A to explain this to you. Listener A. Listener A is stationary, so VL equals to what? 0. Are we clear then? The police car, which is the source, now is moving towards A. Look at my arrow, towards the listener. Look at the arrow here and compare it with the arrow here. What am I going to have? Negative VS. Some learners saying, yeah. Now, FL equals to V plus or minus VL over V plus or minus VS, everything multiplied by FS. That's my formula. Please learn to write the original formula. Now, to make life easy for you, the one that is stationary can simply be omitted because it's 0. So my calculating formula can be written this way: V over V. Remember here we now said it's minus VS, and then you have what? FS. Oh, we have everything we need. What is the frequency of the listener? 690 equals to, take the speed of sound as 340, we are told. V is the speed of sound, over 340 minus VS, everything multiplied by what? FS. I want to do the maths very slowly here. 690 therefore is 340 FS, you're multiplying, over 340 minus VS. Let's cross multiply. 340 FS is equal to 690 340 minus VS. Guys, we do not have two things. Automatically we create equation 1. There are two unknowns. When you see two unknowns in mathematics, then you need to have two equations to solve. Okay, let's deal with observer B. Remember, it's listener again and what? The source. Observer B. Observer B is also what? Stationary. But how is the source moving? The source is moving away. Can you see it's moving away here from B? But in my diagram, my away is now like this. Cartesian plane, plus, negative. Now this one is what? A plus. Okay. Now let's deal with this quickly. What am I going to have now? I am going to have FL, my formula, equals to V plus or minus VL over V plus or minus VS, everything multiplied by FS. Now, let's reinterpret the formula. Again, my listener is what? Stationary. So what is FL? It's V over V. What is your sign here now? Positive. Vs, and everything multiplied by Fs. We can now deal with our substitution. Okay, I hope you wrote that down. 610. Okay, apparently my board is now frozen. All right, and if this is frozen, I am forced to stop this video here. Okay, I would now start the next session, and I'll start from this question and then run through the remaining paper. All right, I hope it's been very beneficial to you. All right, if it's beneficial to you, send us a message, give us feedbacks. We want to hear from you. This is Bishop signing out on this particular session of question 456. Krazifizix, May, June 20, this is February, March 2018, paper 1. This is video number B. We did part A, this is B. Now C would conclude the video. This is 1 hour, 10 minutes. Thank you for listening. Please share the video and enjoy physical sciences.